Hello, my name is Cas Lubbe and this is my video assignment for blockchain. The first topic that I'm going to discuss is the Byzantine general problem. I've chosen this topic because the Byzantine general problem is the difficulty in a decentralized ledger. The individual parts must collectively agree without knowing who's going to do what. The Byzantine general problem is one of the most implemented theories in the development of blockchain protocols. In other words, the Byzantine general problem is in fact a game theory problem. It describes the extent to which decentralized parties find it difficult to reach consensus without trusted third parties. The Byzantine general problem basically asks about the ways in which entities can collectively agree on a specific truth where an entity cannot know the identities of other entities. In addition, the entity cannot know from each other if they are going to do what they say. It is therefore very difficult to be able to trust each other without knowing the nodes and knowing each other. In a centralized ledger, there are trusted third parties we can trust. But in a decentralized ledger, there are no trusted third parties to be trusted. This creates a problem in which collective choices have to be made without being able to trust anyone. That's the Byzantine generals problem. I'm going to make this clearer by using an example. 5 generals are ready to attack a city. Due to distance between the armies, the generals must communicate and coordinate to plan the attack. The generals use messengers to communicate their plans for the attack. However, sending messages through messengers leads to some failure scenarios in the Byzantine generals problem, such as the following. Imagine the scenario where the enemy captures the messenger and tamper with the message, or the generals never receive the message. Or what would happen if the messengers are spies and change the content of the message? Or at last, what would happen if one of the generals is a traitor and sends a false message to the messengers? All these scenarios point to the consequences of not solving the Byzantine generals problem in blockchain. When the Byzantine generals problem is not solved, decentralized ledgers will not function properly and many problems will arise due to the Byzantine generals problem. The Byzantine generals problem can only be solved by a protocol consensus which have to be followed by everybody. So all the entities have to follow the consensus. So that was the first topic. The second subject that I want to explain is how do blockchains work. I've chosen this subject because this whole minor actually is about blockchain, of course, and I think it's really necessary to understand blockchain to understand all the other parts of this education. A blockchain is, of course, a decentralized distributed ledger that is shared between nodes of a computer network. As a database, a blockchain stores information electronical in a digital format. Blockchains are best known for its critical role in cryptocurrency systems such as Bitcoin for keeping a secure and safe and decentralized record of transactions. The innovation with a blockchain is that it guarantees the reliability and security of a data file and gains trust without the need of trusted third parties. A key difference between a typical database and a blockchain is how the data is structured. A blockchain collects information together in groups known as blocks that contain sets of information. Blocks have a certain store capacity and when filled are closed and linked to the previous block, forming a chain known as the blockchain. Any new information following that freshly added block is compiled into a new block, which is then also added to the chain once it's filled. A database usually structures its data into tables, while a blockchain, as the name implies, structures its data into chunks strung together. This data structure creates a kind of timeline of data that cannot be reversed or tampered. When a block is filled, it becomes part of this timeline. Each block in the chain is given an exact timestamp when it's added to the chain. To explain it well and easily, I'll take Bitcoin as an example. The purchase and sale of Bitcoin is entered and transmitted to a network of powerful computers known as nodes. This network of 1,000 computers and nodes around the world try to confirm the transaction using computer algorithms. This is known as Bitcoin mining. The miner who first successfully completes a new block is rewarded with Bitcoin for their work. These rewards are paid with a combination of newly minted Bitcoin and network fees, which are passed on to the buyer and to the seller. The fees can rise and fall depending on the volume of the transaction. After the purchase is confirmed, the sale is added to the block on a distributed ledger, of course. The majority now has to confirm the sale to validate the block. The block is permanently chained to all previous blocks of Bitcoin transactions using a cryptographic fingerprint known as a hash, and the sale is processed. So for a validated transaction, blocks need to be connected by each other through hashes, of course. Miners and minters are constantly searching for these validated transactions, and they will be rewarded for finding them. This makes a blockchain very reliable. All the blocks have to be validated and connected with each other. When a hash isn't validated, the chain won't be right. The consensus protocol for the validation of blockchain is the longest chain is the right chain. So the chain with the most effort in it will be the right chain. In this way, new validated transactions can be added to the blockchain and the timeline will be longer and longer. So after this subject, I want to explain my last subject, and that's the blockchain layers, the different positions in the field. I chose this as last topic because the blockchain layers are used to ensure communication in a clear and secure manner. These layers are actually a kind of rules that apply universally to blockchain. This means that communication is always possible. Suppose each blockchain has devised its own way of communicating. That will be very complicated. Therefore, blockchains can use different layers, so that there are only a few communication options. There's a certain order in the different layers. I'll start with the most important core layer. That is the infrastructure layer. This really is the back end of the system. The blockchain content is stored on a server in a data center somewhere on this globe. Clients request content of data of the application servers while browsing through the web or utilizing any apps, which is known as the client-server infrastructure. Clients can now connect with peer clients and share data by taking part in this whole infrastructure. Decisions in the infrastructure layer will impact all the other layers. It's like the goalie of the soccer field. And then we have the second layer, the network layer. The network layer, commonly referred to as the peer-to-peer layer, is responsible for the inter-node communication. Discovery, transactions, and propagation are all handled by the network layer. Propagation layer is another name for this layer. This P2P layer ensures that nodes can find one another and interact, communicate, and synchronize to keep the blockchain network in a legitimate state. A P2P network is a computer network in which nodes are distributed and share the workload of the network to achieve a common purpose. Okay, then the next layer is the protocol layer. The protocol layer includes the consensus algorithms, the sidechains, the Ethereum virtual machines, and access rights. This is the way of communicating based on a protocol. For example, every blockchain has its own protocol. Think, for example, the proof of work, proof of stake. Even when there is a sidechain, this will have to be communicated with. This is all recorded in the protocol layer. This layer ensures the uniqueness of Bitcoin. The protocol layer has a few components. The first is it establishes a clear set of agreements among the nodes. Up to that, it ensures the power stays decentralized and diffuses, which is very important for a blockchain. It also ensures that one chain is followed, which is the truth, of course. It achieves reliability, and at last, it consists of rules that nodes have to follow. So this is the protocol consensus. After the protocol layer comes the service layer. When we look at the service layer, we mainly look at the direct technology required for the applications. This includes the following. We have data feeds, oracles, off-chain calculations. We have wallets, cryptocurrency, smart contracts, digital IDs, and even more. Users with an application can use the wallet, or they can use smart contracts via dApps. Without the service layer, blockchain will therefore not be able to offer applications that ensure the blockchain is usable. And then, of course, the application layer, we are just talking about that. The application layer contains the products that are directly used by users. Think of the decentralized application, dApps, dApp browser, and programming languages. As an example, we could take Uniswap's website falling with the application layer. This is what you can use. It's the intermediate between you and the blockchain. Users perhaps don't even know that the apps are running on a blockchain. They reap the benefits without realizing what the rear engine is, of course. So this was the layer explanation. These were my few topics that I've explained to you. I found it interesting to delve a little bit deeper into these topics, and I think they really complement each other, so that's why I chose them. This was my video assignment. I hope you really enjoyed it, and see you later.